Assalamualaikum. Alright, in this video we are going to talk on the related rates. So before we could go far, we should ask what is actually dy over dx. So dy is actually the change of y and dx is actually the change of x. So when we write dy over dx, it should be the change of y with respect to the change of x. So next we're going to talk about the rate. So if it is the rate, right, so we're going to talk about time. So we'll have something like, all right, so let's say we have dy over dt. So it should be the change of y with respect to the change of t, which is t is actually time. Right, so if you have dv over dt, so it'll be the change of volume with respect to the change of time. All right, so that is the rate of change of volume. Next, dA over dt, which is the rate of change of area, should be the change of A, all right, with respect to the change of time. Right, next, dH over dt, let's say you have the rate of change of height. Right, so you will have dH over dt, which is actually change of h, which is height, with respect to the change of time. All right, next, we'll have positive and negative rate. If dv, like for example, we have about the volume, all right, dv over dt, which is greater than 0, which is positive, so that should be an increase, right? So it should be an increase in the volume with respect to the time. Yes, there is a change, but the change should be increased or decreasing. So in this case, if it is positive, it should be increasing. All right, what if dv over dt, which is less than 0? That means there is the decrease in the volume, like so for example, decrease in the volume with respect to the change of time. All right, so that's what it means by the positive or negative. So be careful when you have the questions. If it's talking about the change is increasing, so you have should be the dv over dt to be positive. If it is decreasing, if this something like the volume is decreasing, and then it should be negative, dv over dt should be negative. And then we can make a relation, like for example, we want to have the dy over dt. All right, so firstly we can relate to dy over dx, multiply together with the dx over dt. All right, you have to multiply it because we cancel this dx, and dx will have dy over dt. All right, so that's the relation. All right, so to illustrate the related rate, so let's just look at some examples. All right, so we have the first examples here. Right, so the area of a square whose sides have length x is increasing. So what is actually increasing here? The area. Read the question carefully. Right, so the area is increasing at the rate of 8. So another alternative to determine whether it is area or the change of area or the change of side. In this case, we can look at the unit. So the unit is for cm square is actually the area, so we can take out the information that dA over dt. Second is the unit for time. Right, so dA over dt is actually 8. All right, so we know it is increasing, so it should be positive 8. All right, I'll just write positive there. All right, so we know that it is actually a square, so I'm just going to draw a square here with the side which is given by x. So x is here. All right, so we can take note that we can formulate the area which is given by x squared in this case. All right, so that's the first thing that we can do. Right, so next, how fast? How fast means we want to find the change, rate of change. All right, the length of the side is increasing, so we are going to find the rate of change of the length. So now the length is labeled by x. All right, so we want to find actually dx over dt. All right, so we want to find dx over dt when the area is given by 64. So when the area is 64. All right, so we try to relate dx over dt with x when x is to what value, is equal to what values. In this case, we can substitute the a is here. All right, so since the area is already given by x squared, so x squared is given by 64. So to find x, we just take the square root. All right, so square root 64 will have x equal to 8. So I'm just ignore the negative part of 8 in this case. All right, because we are talking about length. So in this case, we don't have negative length. All right, so we just have positive 8 here. Next, we want to find dx over dt. All right, so we try to formulate the, let's say, dA over dt first. All right, so dA over dt is dA over dx, the change of area with respect to the length, multiply with the dx over dt, right? Okay, so this is the part that we're gonna find, right? So we want to find dA over dt is already given by 8. All right, now we are going to substitute. This one is actually given by 8 from this information, all right? Next, dA over dx. Can we find dA over dx? Yes, we can find dA over dx. So we just differentiate these, all right? So we'll have dA over dx. It's actually given by 2x, all right? When the value of x is actually 8, so we'll just write when x is actually 8, all right? So dA over dx will be 2 multiplied by 8, so given by 16. All right, so dA over dx is actually 16, so this is equal to 16 multiply with the dx over dt. Since we want to find the dx over dt, so we'll have to move this 16 to the left side. So we'll have something like 8 over 16 equal to dx over dt. Okay, so we can simplify the dx over dt, all right? So it's given by 1 over 2, or 0.5, which is half, all right? So 0.5. The unit is actually, all right, now we're talking about centimeter, so the x is actually centimeter over dt, so centimeter per second. So it is positive, yes, because it is increasing, all right? And that's the final answer, that we already found the dx over dt. Okay, so that's how you solve these problems of the related rates. Right, let's move to question number 2. Read the question carefully and take out all the mathematical information from the questions. So oil from leaking container radiates outwards in form of circular. So take note that it comes out from the container in form of circle, all right, in the shape of circle on the water surface. So if the area of the circle increases, so we take note that the area of the circle, so the area of the circles is increasing at the rate of this, so we are actually given with dA over dt equal to 400. All right, how fast is the radius? So we are going to find the dr over dt. How fast, meaning that we want to find something over dt, so that something will be radius. So in this case we want to find dr over dt. All right, how much is dr over dt when the area is given by this? So when a, right, is given by 1225 pi. All right, so now we already know that the shape is actually in circle, right? So we'll have the radius, so the area for the circle, all right, because we have the area given, so we'll have to relate to the formula of area for circle. Area of circle is actually pi r squared. So we know that the area is given by 1225 here, all right? So pi of r squared is actually 1225 pi. So we can cancel this pi because it exists on both sides. So we'll have r squared equal to 1225. So pressing our calculator, all right, so square root of 1225, we'll get 35. So radius will be 35. All right, so the r, in this case, because we take square root, it can be positive or it can be negative, but I just consider the positive part because we don't have the negative radius in this case, all right? So the radius should be positive, all right? So we have the radius is actually 35 meter, all right? So now we want to find dr over dt, so maybe we can start with the formula of dA over dt, all right? So dA over dt is given by dA over dr multiply with the dr over dt. Right, now we have the dA over dt, all right, because we are already given in the question that dA over dt is given by 400, so we'll have 400 here. dA over dr, can we find dA over dr? Yes, we can differentiate this function because it is a function in term of r, so we will have dA over dr is given by 2 pi r. All right, so when r is 35, so we can substitute the value of r into this dA over dr. So we'll write when r is actually 35, so we will have dA over dr, all right, is given by 2 pi multiplied by 35. So I will have 70 pi. Alright, so the dA over dr is actually 70 pi. So I'll just write 70 pi here. Alright, so now I want to multiply with dr over dt. Alright, so this is our aim. We just want to find the dr over dt, so we have to move that what do we call 70 pi to the left side, so we become division. Alright, so 400 divided by 70 pi, so this is actually dr over dt. Alright, so it is positive. Why? Because it is increasing, so the radius is increasing, so we can write that dr over dt. All right, so we can press the calculator. So 70 pi, we will get 1.82, right? So 1.82, what unit is it? So because it is dr over dt, so the unit for radius is meter, so dt in this case we are talking in the minute. All right, so per minute, so meter per minute. All right, so that's the final answer for this one. Okay, all right, so next let's move to question number 3. If the radius of a sphere, right, look at the question, read the question carefully. Radius of the sphere is increasing, so we are having the dr over dt. So dr over dt, all right, is given by 4. How fast? How fast meaning that something over dt, but what is that something? Actually volume. So we want to find dv over dt. That's the question. When the surface area, so the surface area is 16. When the area is 16, right? So we have to know the shape is actually a sphere. So what do we call that? Volume and surface area of a sphere. So this one you have to memorize, right? Sometimes the question gives, but sometimes the question doesn't give the information, the formula, so you have to know this formula. So the volume of a sphere is given by the formula 4 over 3 pi r to the power of 3, and the area, the surface area of the sphere will be given by a is actually 4 pi r squared. So this one you have to memorize. All right, so now we want to find the value of a when the value of dv over dt when the dA is actually 16. All right, so we can start with dv over dt, right? So dv over dt is actually given by dv over dr multiplied by dr over dt. Okay, so do we have dv over dt? We don't have. What about dv over dr? All right, so do we have it? We don't have, but we can find dv over dr in this case. So in this case we can differentiate v with respect to r, so dv over dr will be 3, will be moved in front here, so we just copy everything. All right, and to the power of 2 now, so this will be simplified as 4 pi r squared. So this is dv over dr when the area is 16, so we can find the value of, all right, r. Right, so I'll just find it here. All right, so when 4 pi r squared is actually 16, we can find the value of r. Right, so I'll just write in terms of pi now. So I'll have r squared is actually 16 over 4 pi. All right, so I will have, right, I'll just write that. Now I'm gonna substitute this into this formula. All right, so when because we want to find the dv over dr when r squared is equal to 16 over 4 pi. All right, so we can write when r squared is actually given by 16 over 4 pi. All right, so we will have dv over dr is given by 4 pi, so that r squared will be substituted by this value, so 16 over 4 pi. All right, so I'm going to cancel this 4 pi with 4 pi, so I will have dv over dr is actually 16. All right, so I'll just insert into this formula. So we already have dv over dr, which is given by 16, so I'll just write here 16, and then we'll multiply with dr over dt. So we are already given with dr over dt in this case, so dr over dt is actually 4, So our final answer would be 16 multiplied by 4 would be 64. Alright, so the unit should be, right, since it is volume, so in this case, cm to the power of 3, I guess. Alright, cm to the power of 3 and per second. Alright, so look at it, the unit per second. Okay, so that's the final answer for this one. So let's look at the last question here. In a sample of physical apparatus, the distances in a simple physical apparatus, right, the distances x and y are related by this equation. So we are given with this equation. All right, so if y increases at the rate of 18 cm per minute, so we can write that y increases at the rate, so this is actually dy over dt. That's how you read the questions and you take out the information. So it is given by 18, so since it increases, so it will be positive 18. All right, so calculate the rate of which x is changing. All right, so we want to find dx over dt, all right, when x is actually 15. Okay, so to do that, we can find the, what do we call this, we try to rewrite the equation given. So we are given with 1 over x plus 1 over y equal to 1 over 5. So we'll have dy plus dx over xy equal to 1 over 5. So we will have 5y plus 5x is actually given by 5x plus 1, okay, is given by xy. All right, so we can actually differentiate this using the implicit differentiation. All right, so we know that we want to find the dx over dt. All right, so to do that, dx over dt, I'll just write the formula for dx over dt first. So in this case, dx over dy, all right, multiply with dy over dt. We already have the value of dy over dt, which is given by positive 18, and dx over dt we want to find, and dx over dy can be determined. All right, so we will have to differentiate the dy over dx. All right, so, or dx over dy in this case, right, doesn't matter. Suppose we want to differentiate dy over dx. All right, so now we have to use the implicit differentiation to do this. So in this case, differentiating 5y, we get 5 dy over dx plus 5. All right, now we're going to differentiate it with respect to x. So now we'll have x dy over dx plus y. All right, so we will have this. Okay, so now we are going to write the, what we call dy over dx as the subject. So we'll have 5 minus x dy over dx. All right, this is actually given by y minus 5. So dy over dx is given by the formula y minus 5 over 5 minus x. All right, so we know that we want to find the value of dx over dt when x is 15. All right, so when x is 15, all right, so we can find the value of y. So substituting into this formula, all right, so suppose we have, all right, I'm going to use in green color. All right, so 1 over 15 plus 1 over y equal to 1 over 5. I want to find the value of, what do we call this, y. All right, so 1 over 5 minus 1 over 15. All right, so pressing our calculator, we can find the value of 1 over 5 minus 1 over 15. So we'll get 2 over 15. All right, so to find the value of y is actually 15 over 2. Okay, or 7.5. All right, so we have the value of y equal to 15 over 2. So now we know that when the value of x is, all right, so we have the value of y 15 over 2, so the value of x should be 15 in this case. All right, so we can substitute into this formula. All right, so suppose we have this, right, dy over dx given by this, so dy over dx when the value of x is 15 the value of y is 15 over 2, right? So we're going to substitute this value into this function, right? So 7.5 minus 5, right? 7.5 minus 5 over 5 minus 15, right? So calculating this, all right, we'll get 2.5 divided by negative 10. So we'll have negative 0.25. The one is dy over dx, but now, right, we want the dx over dy, right? So since we want to find dx over dy, so we'll have to find, all right, so dx over dy is actually given by 1 over dy over dx. So we will have to divide this with negative 0.25. So calculating this, so 1 divided by negative 0.25 will get negative 4. So the value of dx over dy is actually negative 4. So substituting into this formula, we get negative 4 there. And dy over dt is actually given by 18 from the question. So multiplying this, we will get the final answer, negative 72. And you look at the unit, so the unit is actually dx, all right? So x is actually in cm and it is actually per minute. So we're talking about time in minute, right? So per minute. So why is the answer negative now? Because the x is actually decreasing when when y is increasing. So it is kind of if it is in the physics, so we what do we call it, not that directly proportional, inversely proportional, right? So when something is increasing, the other is decreasing. So the same goes to here. In this case, x is changing. That's why the question doesn't mention is it increasing or decreasing. So from this negative value, we know that it is actually decreasing. All right, so that's it. Thank you.